Welcome to a lab overview of DFS, Distributed File System, on Microsoft Windows Server 2012 R2 Service Pack 0. My name is Daniel L. Benway. I'm a Systems and Network Administrator / Engineer. My LinkedIn, blog, and Twitter information are up on your screen, and I'm going to ask that you use my blog if you want to contact me or check for my most recent publications. Although I do use YouTube to post my videos, I prefer to handle everything else through my blog. This video is freeware and is made in the spirit of open source. You may distribute unchanged copies of it freely to anyone at any time. Care has been taken to cite contributing sources and individuals. Please do the same. If you find errors herein, please comment on them and/or contact me so that we may all contribute to the community. We've got just about a half a dozen slides to get through, and then we'll be doing the rest in the virtual lab. DFS provides three major things: namespace, namespace topology redundancy, and content redundancy. Namespace provides for the grouping of shares from many physical locations into a single logical location. It presents a simplified structure to the end users, is easier to use, easier to search, etc. And it actually exists as links to shares in the DFS roots folder on all servers that host the namespace. Namespace topology redundancy is optional. It's accomplished by configuring multiple namespace servers to host the namespace. Content redundancy is also optional, and it's accomplished with replication groups and replicated folders. It can be used even without an accompanying namespace. It speeds performance by distributing files and making them available on nearby servers. It provides fault tolerance, is multi-master, and uses remote differential compression to replicate only changes within files. When should we use DFS? DFS is designed for relatively static content where version control is not needed. We should not use DFS on files that change frequently, like databases, user profiles, and PSTs, which, incidentally, are not even recommended for LAN/WAN access, much less DFS. We should also not use DFS for files that are changed by multiple users. DFS crudely handles version conflicts, but does not provide real version control. There are two types of DFS namespace: standalone and domain-based. Standalone is accessed at // servername / DFS root name, and only one namespace can be built on any server. Domain-based is accessed at multiple addresses: // netbios domain name / DFS root name, which is probably easiest for end users, // fully qualified domain name / DFS root name, and // the name of any DC in the domain / DFS root name. Many namespaces can be built in a domain, and it can be set up on DCs and/or member servers, but not standalone servers. There are two server roles germane to a discussion of DFS or DFSR: the DFS namespaces role and the DFS replication role. The DFS namespaces role is used to host, create, or change a namespace. A domain-based namespace does not have to be hosted on a DC, but it must be hosted on either a DC or a domain member server, not a standalone server. And just because one DC hosts a domain-based namespace, it doesn't mean that any other DC automatically also hosts that namespace. Namespace host servers must be manually configured. The DFS replication role is used to participate in, create, or change DFS replication. On a DC using DFSR for sysvol, the DFS replication role is not installed by default, and once an administrator installs the role, it cannot be removed, so long as the server is a DC using DFSR. A good rule of thumb: installing either of these roles will install the DFS management console. I recommend installing both roles on any server in your DFS infrastructure and also on your DCs if they're using DFSR for sysvol replication, instead of the older FRS. In addition to administering DFS and DFSR with the GUI, you can also use command line interface and scripts. You can use DFS command, DFS util, and DFSR admin. When troubleshooting DFS and DFSR, you can use DFS diag. You can generate a health report with either the GUI or DFSR admin health. Now, in the lab, we'll take a look at using the GUI to generate a health report. You can also use DFSR diag and, of course, the DFS replication event log. We're done with the slides, so let's go ahead and head off to the virtual lab. So here we are in the virtual lab. We have two virtual machines running. Both are domain members. They're on different subnets separated by a router. The system on the left is file and print 1. The system on the right is file and print 2. Both systems have just a C partition. This is just a simple lab. And in the root of C on both systems is a data directory. The system on the left, the data directory contains folder 1 and folder 2. Folder 1 contains file 1, folder 2 contains file 2. And the system on the right, the data directory contains folder 3 and folder 4. Folder 3 contains file 3, folder 4 contains file 4. Neither system has a DFS roots directory, and both systems, the only thing aside from the system shares are folder 1 is shared, folder 2 is shared on the left as share folder $1, share folder $2. And on the system on the right, folders 3 and 4 are shared as share folder $3 and share folder $4. The next thing I'm going to do is show you that the DFS management console does not exist on the server on the left, nor does it exist on the system on the right. Now we'll go in and install both roles onto both systems, and we do that from within Server Manager. The roles are in File and Storage Services under File and iSCSI Services. The DFS Namespaces role and the DFS Replication role. Once the installation has been completed, we'll go ahead and close out of both. And then we can see the DFS management console is now in the server manager of both systems. So now that both roles have been installed on both systems, let's take a look at the services on these two systems. You can see we've got the DFS namespace service and the DFS replication service. Both are automatic, both are running. And on the second system, we should see the exact same thing. Here's the DFS namespace role and the DFS replication role, both automatic, both running. The next thing we're going to do is actually create a DFS namespace. But before we do, when we refresh the C drive on FP1, you see there is no DFS roots folder. And when we do the same thing on FP2, again, there's no DFS roots folder. What we're going to do is go into Server Manager, open up the DFS Management Console, right-click Namespaces, and choose New Namespace. The server that's first going to host this namespace is going to be the current server, DLB FP1. The name of the namespace is going to be Sample DFS. When we edit the settings, we see FP1 as the server, Sample DFS is the shared folder, and the path is DFS roots sample DFS. We're going to give administrators full access and others read and write. This is just a simple lab. We're not going to go crazy with permissions here. This is going to be a domain-based namespace, not a standalone, and we're going to enable the newer Windows Server 2008 mode. The namespace has been successfully created, and you can see here it is. Now, on the back end, when we refresh the root of C, here's the DFS roots folder. And again, on the second server, when we refresh it, there's no DFS roots folder because the namespace is currently only being hosted on DLB FP1. When we go into the DFS roots folder, we see the sample DFS folder is in there, but there's nothing in it because we haven't yet added folders to the namespace. We've simply created the namespace. The next thing we're going to do is actually add the 4 shares to the DFS. But before we do, remember that on the left we've got folder 1, folder 2. Those are the names of the folders, and they are shared as share underscore folder $1 and share underscore folder $2. On the right we've got folders 3 and 4. Those are the names of the actual folders, and the shares are share underscore folder $3 and share underscore folder $4. That'll become important as we start looking at how things are actually configured on the back end. Now we're going to go ahead and actually add the 4 shares to the DFS namespace. We do that by right-clicking on the namespace and choosing New Folder. And we're going to give this folder within the DFS namespace a name preceded by DFS underscore, just to make it clear that this is the folder within the namespace, not the file system folder and not the share itself. We browse to FP1 and here's the share itself, share folder $1. Now we repeat the process for the second folder. Now for the third folder. We'll have to change this to FP2 because that's where the share for the third folder exists. And the fourth folder. Okay, so we've added the 4 shares corresponding to folders 1, 2, 3, and 4 to the DFS namespace. Now when we actually go to the DFS roots folder, here are the links to the shares themselves. Notice we can't actually access any content from here. These are just links that the DFS uses internally. But let's look at the ways we can access the content. We can go to // DLB test, which is the NetBIOS name of my domain, /sample DFS, and here is the actual content with the actual files. Okay. Another way we can access the content is with a fully qualified domain name, dlbtest.priv. Let's look at another way we can access the content. This is the name of the first of 2 domain controllers in this domain. And lastly, this is the name of the second of 2 domain controllers in this domain. So you can see there are many different ways we can actually access this content. Like I said earlier in the lab here, the best way to tell your end users is just to use / NetBIOS name of your domain / DFS root name. Now we're going to add namespace topology redundancy by adding a second namespace server to the DFS namespace. We do that by right-clicking on the namespace and choosing Add Namespace Server. The name of the server is DLB FP2. And again, we're going to give administrators full access, everyone else read and write. And now, when we click on the Namespace Servers tab, we see both FP1 and FP2. When we go to the second system, we see the DFS roots folder now exists. Let's refresh and alphabetize it. It's right here. Now, on the first server, we see that folder 1 and 2 exist, and on the second server, folders 3 and 4 exist. So the folders haven't changed. The only thing that has changed is that DFS roots now appears on both the left-hand server and the right-hand server. And on the left-hand server, we've got the sample DFS with the 4 links. On the right-hand server, we've got sample DFS with the 4 links. The shares haven't changed on either system. Now that namespace topology redundancy has been created, let's look at what that really means. Folders 1 and 2, shares 1 and 2 exist on the left. Folders 3 and 4, shares 3 and 4 exist on the right. Both systems are in the DFS namespace. But if the left-hand system were to go down, the namespace would be available, but the content from folders 1 and 2 would not. The content from folders 3 and 4 would be available. If, however, conversely, the server on the right were to go down, then the namespace would be available and the content from folders 1 and 2 would be available, but the content from folders 3 and 4 would not be available. What I'd like to do next is to call up the 2 domain controllers for this domain. We've got DLB ADDS1 on the left, ADDS2 on the right. When I open DFS management on these systems, you can see that the namespace is not showing up here because this server, this Active Directory domain controller, is not hosting the namespace even though the domain is. The second thing I wanted to show you is that the domain system volume, i.e. sysvol, is being handled by DFS replication. If we go to the second domain controller, we find the exact same thing. There's no namespace and the domain system volume is being handled by DFSR. Just wanted to point that out for the sake of completeness. Now we're going to start setting up content redundancy. The way we do that is by building a replication group. Right-click on replication, left-click new replication group. This is going to be a multi-purpose replication group. The name of it is going to be sample DFS _ rep group. We're not going to worry about the description for a test lab, and the domain looks good. Next, we add the servers that are going to be members. DLB FP1 and FP2. It's going to be a full mesh topology. We're going to use full bandwidth because, again, this is just a test lab. Now, the primary member. Well, the first thing we're going to do is set up folders 1 and 2 to replicate from the left-hand server to the right-hand server. Being that they exist on the left-hand server and not the right-hand server, we're going to make FP1 the primary member of this replication group. The local path of the folders to replicate are C data folder 1. We're going to let DFS refer to it as folder 1, and we're going to keep existing permissions. And C data folder 2. We're going to let DFS refer to it as folder 2, and we're going to keep the existing permissions for that as well. Now, we need to specify where folder 1 from FP1 will be stored on FP2. We're going to store it in C:\\data backslash folder 1. We'll let the folder be created on the target FP2. And now we need to specify where do we want folder 2 from FP1 to be stored on FP2. And that'll be on C:\\data folder 2. Yes, we want to let that folder be created as well. Review the settings. Everything looks good there. And create. Everything is successful. Replication will not begin until the configuration is picked up by the other members of the group. That's fine. We'll let that go ahead and work on the back end. Now, after just a couple of minutes, we can see that the data directory on the left contains folders 1 and 2. The data directory on the system on the right now contains folders 1, 2, 3, and 4. On the left, folder 1 contains DFSR private, which is an internal DFS link, and the content file 1. The same is true of the system on the right. Notice the system on the right, folder 3 and folder 4 just contain the content. They don't yet contain any internal DFS links. Next, we're going to set things up such that folders 3 and 4 are replicated from the right-hand server to the left-hand server. And we'll do that within the replication group, adding new replicated folders. The primary member this time is going to be FP2 because the files currently exist only on FP2. The local path that we want to replicate, folder 3. We're going to let DFS call it folder 3. We're going to keep existing permissions. And folder 4. We're going to let DFS call it folder 4, and we'll keep existing permissions. Now, we need to say where we want folder 3 from FP2 to be stored on FP1. We're going to put it in C:\data folder 3. And we'll let DFS create that folder on FP1. Next, we need to tell DFS where we want folder 4 from FP2 to be stored on FP1. And we'll let DFS create folder 4 on FP1. We'll review the settings. Looks good. Everything is successful. We'll let replication catch up for a few minutes and I'll pause the tutorial. After waiting just about a minute or so, we can see that the system on the left has got the data directory and the DFS roots directory, as does the system on the right. The system on the left in the data directory has got folders 1, 2, 3, and 4, as does the system on the right. The content of the DFS roots directory on the left is sample DFS with links to folders 1 through 4, and that's exactly what we're seeing on the right. On the left, the only folders that are shared are folders 1 and 2, and on the right, folders 3 and 4. This is important to note because by creating the replication of folders 1 and 2 from the left to the right and folders 3 and 4 from the right to the left, no new shares have been created. And we'll take a look at that in just a minute. Now that we've got content redundancy set up mostly, I'd like to talk about something that's bad practice. In the DFS roots folder on either system, you've got the sample DFS folder, which is the root for our namespace. Oftentimes, I see people putting content in this folder. That's a bad idea. It's also a bad idea to store content in the DFS roots folder itself, and we'll call this bad practice 2. The point I'm trying to illustrate is, although you can store content in these folders, it's bad practice because you want your DFS roots folder to simply contain the links and the structure of your DFS. You want your actual data to be stored elsewhere, preferably in a data folder or on a data partition. So don't store content here. Let's just get rid of these. And store content instead in a data folder, preferably on a data partition. Now that we've got replication set up, let's go into the console and take a look at a few important things. If we go into replication, we see that folder 1 is on FP1 and FP2. And that's also true for folders 2, 3, and 4. That's exactly like what we would expect. What's a little strange, however, is that if we go into folder 1 in the namespace, we see that it's only being served up by FP1, as is the case for folder 2. But folders 3 and 4 are both being served up by only FP2. Now, that actually makes sense considering that folders 1 and 2 are only shared on FP1, and folders 3 and 4 are only shared on FP2. The way to create true fault tolerance and redundancy is to go ahead and create new target folders. To do that, we'll first go to DFS folder 1 and add a target folder. It's going to be on FP2, and it's going to be folder 1. That share does not yet exist, so we will create it. The local path on FP2 is going to be data folder 1. Administrators will have full access, everyone else will have read and write. We're not going to create a replication group because we've already done that. The next thing we will do is folder 2. We'll add a target folder for that. That's going to be on FP2, folder 2. The share does not exist, so we will create it. The local path on FP2 will be folder 2. Administrators will have full access, everyone else will have read and write. We're not going to create a replication group because we've already done that. Next, folder 3. New target. This will be on FP1, folder 3. We will create the share. The path on the local system is folder 3. Administrators will have full access, everyone else will have read and write. And we're not going to create a replication group because we've already done that. Lastly, folder 4. New target. This will be on FP1, folder 4. We will create the share. The local path will be folder 4. Administrators will have full access, everyone else will have read and write. And again, lastly, we're not going to create a replication group because we've already done that. So now, let's look at the shares that exist on FP1. We now have shares 1, 2, 3, and 4 for folders 1, 2, 3, and 4. And on FP2, we have shares 1, 2, 3, and 4 for folders 1, 2, 3, and 4. Let's take a look at the console again. Now we see DFS folder 1 is now being served up in the DFS by FP1 and FP2, as is folder 2, as is folder 3, as is folder 4. That's exactly what we wanted to see. I just noticed that our replication group is not properly named. This should be sample DFS _ rep group, not reg group. I just wanted to point that out in case there was any confusion about that. The next thing we're going to look at is how to generate a diagnostic report from the GUI. We right-single-click our replication group and we choose Create Diagnostic Report. We're going to generate a health report. It's going to be stored in DFS reports with a report name that's automatically generated. We're going to include both of our servers in this report. We're going to count backlogged files using DLB FP1 as the reference member. These options look good. We'll close the wizard upon completion. And here's our report. You can see that we have 2 servers with no warnings, no replication errors, no servers unavailable, and no replication warnings. Down here, we can expand the individual servers to look more deeply into what's going on each individual system. Next, what we'll do is we'll do a propagation test. We're going to use folder 1 based out of FP1, and we're going to delete all test files older than 90 days. Close the wizard upon completion and create that. So the propagation test is running at this very second. It's a very quick test to run. It's very quickly completes on a small, well-routed network like this. So let's go ahead and go back into Create Diagnostic Report, and this time we'll look at the propagation report. Based off of folder 1, off of FP1, and we're going to drop this down to 1. We're just going to look at the last one we did. There's our path and our name. Close the wizard upon completion, and here we are. So we see that the propagation tests, there's been 1 completed test. There are no incomplete tests, no tests with errors. So that's just a quick way you can get information on the health of your DFSR from the GUI. Thank you for joining me on a lab overview of DFS, Distributed File System, on Microsoft Windows Server 2012 R2 No Service Pack. Again, my name is Daniel L. Benway, and if you'd like to contact me or keep up on my publications, please do so through my blog. Make it a great day.